Let's talk about your assignment 11. As usual, the assignment 11 we will do, the first part is to complete your header file. So usually we finish that in the lab exercise. But don't forget, you still need to fully test your program. So this hash table template, actually they have exactly the same public interface as the associative array, what we have before. So on the other hand, you can also just adopt from your associative array test driver to test your program. So the same thing, you have two choices to implement your hash table. You can either do linear probing, so here we have, or you can do the chaining. But the chaining, actually, I want you to using the updated chaining implementation I include in the lecture video. So you need to make sure your chaining implementation, they should have two different load factors. One is for the size, how to see the array, how busy the array is. Then the other one is for the node, load factor. So that's why this can, using these two load factor information can help us to really know, to make sure the average size for each list, they will have the performance for big O1. Right, so that's very important for the hash table. The most important thing when you implement that, you are based on your getter function, setter function. All their runtime should be constant big O1. So that's why after you finish your part 1, our part 2 actually is quite easy. Your part 2, actually, we just want you to revisit your DVC scheduling version 1 in our assignment 4. If you remember, that's the biggest program you have, the runtime is so long, right? So if you use the regular i5 machine, so your runtime usually be a couple minutes or a few minutes. But now that's the V1 is so slow because we're using the only have one-dimensional array. So that's our runtime is big O n squared. But now since we have the hash table now, our hash table, the searching time only is runtime 1. So then we'll bring down all the duplicate check, runtime become big O n. So that's why here you have two things you need to pay attention. In order to maintain big O1 behavior in the hash table, the first thing, your hash code function, you need to choose wisely. Then the second thing, you need to check your capacity for your hash table. Are they good size to distribute those information? So the first thing that I see here, if we want to use the hash table to do the duplicate check from version 1, how should we do that? Okay, so it just say, for example, actually this one here, my hash code function, on the size for the cap, possibly they are not enough. I just say, for example, okay? So you just be careful. This one is not really you have to using this number. It just say, for example. So then we have our record for the hash table. You see only one dimension. The key is string. I just want to see if this section exists or not. So the capacity will give them 7,500. So maybe enough, maybe not enough. Okay, so then your hash table. So then we have the other one is the subclass. So that's for the subject. So the same thing, your key is subject name. So then here we just want to see each subject, how many sections they have. So let's have 100 first. Okay, so after we have that definition, is that enough? We need to think about. So when you use the non-duplicate record, we need to think about, actually, we already know in our DVC scheduling, did you remember total we have how many lines? Right, we have 85K plus line, right? So on the other hand, when you decide your cap, you need to think, is that enough? So then one thing is need to think about, you want to do the linear probing or you want to do the training. Okay, so we just see here if for training. For training, you need to be careful. Training actually is each node is a list. So that's why if I have 85K line, so even each node, if I can have like one node or two nodes, that would be good, right? But still, if I have my capacity is 7,500, for 85K, actually become my average for every node list. They will have 10 nodes in each list. I think that's not good enough. So actually for training, it's better you have at least like 75,000 capacity. So that's why here we can maintain maybe each node only have, each element only have at least contain one or two nodes. So that's our runtime can be big O1. So then the next one we see here, the class, the subject. The subject actually, remember we have like 120 subject. So training 100, okay, maybe good enough. Yeah, but if you want, you can increase that. Okay, so that's why for training. But for probing, that's also other story. So if for probing, if for linear probing, remember I need to have the load factor under 50%. So that's why if I have 85K line, supposedly I should have at least 200,000 the cap for my non-duplicate. Okay, so the same thing for the subject code. Subject code is 120, right? So that's why we need to under 50. So 200 even not enough. So then we need to have like kind of 300. So that's why for different implementation, consider the load factor. You need to think wisely how you will have your hash table capacity defined. Okay, but one thing is after you define your hash table, the good thing is your duplicate check is quite easy because now we have the key, right? So that's why duplicate check, remember your class code is term plus section together. For example, you have one section is for 2019. So the section is 3666. So then since we make this one is a bool, so we just need to check if this section happened before. If not, if it is, so that's duplicate. So if not, actually you just need to add your non-duplicate one into the record. Then your subject class, the same thing, increment by 1. Yeah, that's your duplicate check. Easy and simple in few lines. Okay. But this assignment is not that easy. This duplicate check is easy. But what I want for this assignment is you need to pay attention for the runtime. So this assignment part 2, the runtime actually I expecting in couple seconds you need to finish your runtime. Okay, so your runtime should be couple seconds only. So if any runtime is more than 3 seconds, it's not acceptable. So for this assignment part 2, in your output, not only you need to tell me how many duplicate number you have, and we still need you to show how many sections in each subject. But here you only can use the STL container. That's mean no more static array, no more dynamic array. You can use your STL container. You can use the set. You can use the vector. You can use the array. So to display the output in the sorted order for the subject code. So addition to that, I want you have not only the duplicate check number, I want you to include your load factor and the total runtime for this part. So that's why here, let me show you. After you have this duplicate check, right? So then you display your subject code in the sorted order. That's the sample output. Your sample output is still the same. You need to have a duplicate check number. You have your total record. So then you have total subject. So each subject in the sorted order, how many sections. But I also need your hash table capacity and the total runtime. So that's why here I want to show you some bad example and good example. So this one, actually, the total runtime for the linear probing is almost 4 minutes. It's totally not acceptable. The reason is the hash code function. So you really need to think about for this homework assignment is what the hash code function you should use for the duplicate check. Before we did talk about if you have a string, you can add all the ASCII value to find your to convert to the integer, right? Right. This one for the subject code is fine because all our subject code you can see they have good distribution. They have different lengths. They have different character. So and also they only have less than 120 subject. So that's why if you just add ASCII value, they will be in good distribution. But the problem is not subject code, it's your duplicate check. Don't you see your duplicate check for 2019 and your section number? If I try to add those numbers together, you see they are all ASCII value. After they add together, they may be just few hundred. And they all in that few hundred, right? No matter what kind of section. If they only have few hundred, that means between 0 to 1000 for the index. Already good enough. But total, we have how many lines? We have 85K line. So on the other hand, remember I showed you before, right? So before I show you, if you have your array, that's a cap. Okay, so that's what I want to show you is you need to be very wisely to use your hash code function. If your hash code function, you see here, my capacity is 0 to 200,000. But if your value is only limited to 0 to 1000, yeah, that's your convert your key to index. That means my array is that big, but your index only center located in here. They didn't really distribute very well. So for the linear probing, they will try to find hard for the next not in use one. So that's why did you see your hash code function is so important. Your hash code function is so important. So that's why I show you different example. My example one, actually this one is my hash code function for the duplicate check. Even I already tried to make the section number just using the number itself to add together instead of the ASCII value. But they still distribute very badly. So the runtime is almost 4 minutes. But afterward, I changed my hash code function. But I don't show you how I changed that. I want you to think your own way to change the hash code function. So supposedly your runtime should be what? So that's my example 2, my sample output 2. So then I still using the linear probing. My capacity is 200,000 and 300, but the runtime is within 1 second. That's because I only change a little bit for my hash code function. Your purpose is your hash code function, you need to make sure your key convert to the index. The index can distribute evenly through that 0 to 200,000 index. The value distribution is very important. So that's the linear probing. So then you need to think about your hash code function. So if you choose for the training, right, the same thing. So training actually the same thing. If I just using this hash code function, I'm already good enough. On training, the capacity doesn't need to be that big because we have the list on the node. So then you see this one is within half second. But the average for the list node size is each list I have about 9 nodes. So I'm using this hash code function. So then the training too. The training actually even the 12 second No, I'm not acceptable. It's not acceptable for your runtime. Okay, so make sure your runtime should